Hello guys, in this video we will basically look at the various versions of the LED rings that we built. The first version we built was built using an SMD LED. We basically used the 2mm by 2mm WS2812 serial addressable LED. So we mounted the LED on this board. So we thought we will actually have at least 4 by 2, basically 8 rings in one single board. And since it's going to be mounted on the board, we basically thought we would require some sort of a semi-transparent mask over the LED so that it shines through. And then we thought, okay, to demarcate it, we will actually add a sort of opaque ring around it. So that is this ring. So we used acrylic for both. And this is basically the final display where we actually have the LEDs mounted on the board, and then we placed it's more like a semi-transparent gray color acrylic, and then on top of it we have the opaque acrylic. So this is that design, and when we actually turned it on, it looked really good actually, so we really liked it. The biggest challenge with this was, even if one LED fails, the whole chain fails, which means that if one LED in the first LED ring failed, everything will fail. So this was a big challenge for us. The second issue was, even though the diffuser looked good, we found like when we wanted to place it on a different kind of an environment where we wanted to have an individual hole for basically the encoder, something like this, it didn't look good. So we had to place another white diffuser below it, and then through that we looked at it. But the original problem kept coming back up, where even if one LED fails, the whole sequence fails, and it was not something that we wanted to do. Second thing we thought is, okay, in case we are not able to basically get the diffuser working, we thought we'll create a LED light pipe. So we took pure clear transparent acrylic and cut those shapes, the shapes that you see here, and we thought we will use that as a light pipe instead of a diffuser. So that is our second attempt over here. So here you can actually see the holes in the 5mm opaque acrylic, and we've actually placed the light pipe over here. The reason we have light pipes here, even though we didn't use it in this scenario, it became very useful for another one when we actually use the keyboard. I'll show that later. And so here you can see that mounted. So here we created two styles of LED light pipes, one which is flat on top and one which is curved on top. You can actually see both in this. So the curved ones are actually slightly curved on top, and you have the flat ones, and we found the curved ones look a little better than the flat ones. So this is when we actually light up the LEDs. So this looks pretty nice. But finally we decided, something, this is not going to work with all the serial LEDs. So we went with a different approach totally. The approach we went with is basically using a through hole LED. So this is a 2mm by 5mm rectangular LED, through hole LED, that we mounted on a PCB, and we basically used red, green, blue at the bottom, round LEDs initially on version 1 to drive this. So we essentially use the Max 7219 8x8 LED matrix driver. So one of that IC can actually drive up to 64 LEDs. Since it can drive up to 64 LEDs, we decided we will use one board that can drive 4 LED rings. So that is the one that you can see here, and this is basically the module mounted onto the 5mm thick black opaque acrylic, and this looked pretty good. So we decided, okay, this is the right way to go. This way we were able to solve the issue of one LED failing affecting rest of the LEDs. And here you can actually see the whole unit of how the LED rings look along with the encoders. Thank you.